In the last video I showed you how to download and install R and how to install that DPLR package, the Dendrochronology program library. And that's what we're going to use to detrend and standardize our ring width measurements into ring width indices and create one tree ring chronology from our site. So let's go ahead and do it. Now, what I have here is all of the code to detrend my series. I have this in a text editor. When you're working in R, I recommend using a text editor because you can type in all the commands to do the thing you want to do ahead of time. You can annotate those commands with little notes to yourself of how you did it. You can run all the stuff at once in R, and then you can go back and fix stuff if it doesn't work. Also, if you save these text files, you'll have something to refer back to if you want to do the same analysis again, maybe using different data or something like that. The text editor I like is called TinR. It's available for free on the internet. But there's many text editors out there. I mean, Notepad is the default text editor in Windows, and TextEdit is the default in Mac, but there's many other really good options. RStudio is really good, and so on. But for this project, because there's, at least at this stage, there's very few lines of code, you can probably just get away with typing these commands directly into the R console. But I'm gonna use my text editor to show you how that works. Okay, so this is TinR. It's a text editor that's linked with R, so I can click my little button here and start running R. So I have my R window at the bottom of the screen here, and I have my text editor window at the top. Now, when you put comments in, so you see my comments are in green, and all you have to do is put a little hashtag. And if you put a hashtag in, R will not run the code on that line. It just ignores it because it's just notes to yourself. You know, so that's for humans, and the lines without hashtags is for the computer. So I put a little header in here, the date, and what I'm trying to do. And so the first thing we need to do in R is set our working directory. So this line of code right here, I'm using the command set working directory, so set WD, and then in parentheses I'm putting the path to the folder that I set up. So I have my folder down here, BL460, so it's on my C drive, and this is where I have my data. There's where I have my ring width list, so all my measurements. So you need to set that file path to tell R where to look for the data. So I set working directory, parentheses, and then apostrophe or quotation marks, and then my path here is C:/ and then the name of my folder, BL460 project1. So make sure you know where your folder is located and type the path. If you're working on a Mac, you do something different. I don't know what the hell Mac people do, but there's a different path that you'll specify. So show R where the data are. So I'm going to hit, if I on my computer, if I just hit my F4 button, you see that command now pops down into my R window. So R has now set the working directory. The next thing you need to do is load in that DPLR package. That's a series of tools and stuff that somebody was nice enough to program that does tree ring analysis. So we're going to, again, I'm going to move this line down to my R window, so I'm going to run that. If you're working just with the console, you would just type in library parentheses DPLR. Okay, so I got a little warning message that this was built under R version 3.1.3, and I'm running version 3.1.2, so I'm running an older version of R, but it shouldn't make a difference. Anyway, okay, the next thing I'm going to do is load in my data. So see what I'm doing here with this line of code. So this says CO580. So I'm creating a variable called CO580, and I'm using that assignment operator, and I'm saying put in this variable, and I'm using this command read.rwl. So that means read a ring width list file, and then in parentheses I'm telling it which file to read. So my file is CO580.rwl. I put that in apostrophes here, or in quotation marks. So I'm going to read in this file, and I'm going to put it in a variable called CO580. Okay, so let's run that line of code, and there it is. So in my R window, let me make that bigger. In my R window, I ran that command, It says assuming a Tucson format, which is correct. There's not a header. I don't have any lines of text ahead of it, and there are 25 series. So I've got 25 cores, and you can see it shows my beginning year, my ending year, and the precision. So this means those cores were measured to a precision of 1,000th of a millimeter, 0.001. Okay, so far so good. The next thing we're going to do is what's called interactive detrending. So in the last video I mentioned how detrending works. We fit a function, a mathematical function, to a series, and then we take the residuals. So I'm going to create a new variable called ring width index. So CO580 up here is millimeters. I'm going to create a new variable called CO580.rwi. You can name it whatever you want. It's your choice, your variable. But I'm going to call it ring width index, and I'm going to use the function iDetrend, and then I'm going to tell it I'm going to detrend the variable called CO580. The other command you'll put in here, so put a comma to separate them, and then NYRS equals 50. What that means is if I fit a spline function, so not a negative exponential curve, but a polynomial spline that can kind of curve a few times. This is the number of years, NYRS, the number of years that that spline can curve. So I'm going to use 50 years, which is pretty flexible spline. You can try different values and see what happens. But I'm going to use 50. So I'm going to go ahead and run this line of code. And what's going to happen now is it's going to go series by series. So we see a new window popped up, and this says series LAN072. So that's my first core. And so what this has is several different options. So what's showing down here in these panels, this is the ring width index for that series if I fit a spline. This is what happens if I fit a negative exponential curve. This is if I fit a horizontal line. And then there's another sort of spline called a Friedman super smoother, which we don't have to worry about too much. So what I can see is that this looks pretty good. My green series, my spline, as I would expect, the values are spread above and below a mean of 1. It's a pretty nice flat line. And here we can see that green line fit through the data. The black line here is the raw ring widths in millimeters. And you can see my green line fit, my negative exponential line, and so on. The green line goes kind of right through the series, so that's showing it's a pretty good fit. There's not going to be any weird outliers in here. So over here in my R window, what I have is it's saying enter a number. So I can enter 1 for spline, 2 for negative exponential, 3 for the mean, the horizontal line, 4 for AR, which don't worry about AR, and 5 for Friedman. So I'm going to enter spline because that looks like a good fit to me. So 1, enter. Now we go to the next series. So here we have LAN111, and we have the same options. And so again, my spline looks like a pretty good fit. So I'm going to go ahead and use the spline. So I'm going to enter 1. Over here, look at this weird series, right? So this one's kind of, the wiggly line is going pretty flat, and then we have a growth release, and then we have a curve down. So you see a negative exponential line is not going to be able to fit that because there's too many different changes in the slope of the trend. So the green line is going to be really good for that. So I'm going to use the spline again. So I'm going to go ahead. I've looked through these before starting the video, and so I'm going to hit 1 for all of these, and I'm going to use the spline. And I recommend a spline is probably going to be a good fit. Here, see the negative exponential is not too bad. The red line is negative exponential, and that's a pretty good fit through the data, except, look, there's a little tail, a little trend up here. So if I use the negative exponential, these values are all going to be larger than 1. So you see down here in my red panel, the residuals here, you see these are all positive. But these ring widths, that doesn't mean that those are all super wide rings. It just means that there was a trend that we didn't smooth out. This is a wide ring up here, but this is a narrow ring down here, and those would all be sort of positive. So that's why the spline is a better fit. It's going to follow that trend upward on the tails. That's usually where you need the spline. So I'm going to go ahead and enter 1, and I'm going to go ahead and put in a spline for all of these. So I'm using the same curve fit for every series. And we'll get to the end. I think there were 25 series. So there. Okay. So we got a few warning messages here, but we don't need to worry about those. So all of the series are detrended now. Okay. So we can close the graphics window. And let's go back to my code. The next thing I'm going to do is average all of those. So I've detrended all those series. So our co580.rwi is a list of all my detrended series. So ring with index instead of ring with measurements. Now I'm going to use this function, the chron function, to create a chronology. So I'm going to create a new variable, and I'm going to call it co580.std for standardized. And I'm going to just use this a chron function, and that's going to average all of them into a chronology. So let me send that command down to R. So there we go, we've done it. Now all I have to do is make a plot of the chronology. So I'm going to use this crn.plot function. I'm going to tell it to plot this variable, so the new chronology that I created, co.580. And then I have some different commands in here to add some labels to the graph, to tell it what color lines and so on. If you copy those exactly, you'll get a plot that looks exactly like mine. Again, you can mess around with those if you want, and you'll see what you can do. You get different colors and so on. Okay, so let me send this line to R, and there we go. Here's the plot, and I can sort of resize it. So what I've created here, so here's my years, both along the top and bottom axis. So my chronology goes back into the late 1300s. The gray shading is my sample size. So over here, my sample depth, I've got a little over 20 samples, and then it kind of drops off as we go back through time. And then the black line is my chronology, so my average ring width index for the whole site, so we can see which years are wide and which years are narrow. This is the data that we're going to compare with climate data to run our climate growth analysis. So you'll probably want to save this figure and include it in your report. And then the other thing you want to do is save the data, because that's what we're going to run our climate chronology with. So the way to do that is you can just, in your R window, you just type the name of this variable. So my chronology is called co580.std. Hit enter, and here it is, right? Here's all of my years. This is the values for each year, right? So from 1382, my value here is 0.721, and then my sample depth too. So I'm just going to go ahead and highlight all that and copy it, and then I'm just going to paste it into another text editor window and save it. And we're going to use these data in our climate analysis. This is a pretty long chronology. There we go. Okay, so Control C to copy, and then I'm going to go back to my text editor. You can do this in Notepad, so just open up Notepad. Control V to paste. There are all my data, and then I can save this in my folder. So C drive, BL460, and I'm going to save it as I'll call it co580 chronology, CRN, and save it as a text file. Great. So that's how you detrend, and you'll get a chronology. And in the next video, I'll show you how we obtain our climate data, and then in the video after that, I'll show you how we actually do our climate and tree growth analysis.